Hello, good evening, and welcome to this session. So in this session, we will see some problems based on JEE Advanced. This series will be for the 100 problems, and in this session, we'll see how many problems we can do. Let's go ahead. So looking at the first question, we have here a function, differentiable function satisfying cube root of f of x plus y is equal to cube root of f of x. Cube root of f of x plus y is equal to cube root of f of x plus cube root of f of y plus 1. And now we are given that f dash of 0 is 3. So g of x is f of x minus x cube. So I want the number of points where my function is not differentiable. This we need to find out f of x. So we will do one thing. We will differentiate with respect to x partially. So I'll differentiate this function with respect to x partially. So what will happen? This will be 1 upon 3 here. Then f of x plus y would be as it is. And then derivative of f dash will be f dash of x plus y here on s2 over 3 is equal to, now this would be simply 1 over 3 into f of x to the power, again minus 2 over 3 into f dash of x. Now let's go ahead. So we can get this 1 over 3 cancelled and transfer this guy here. So f of x to the power 2 over 3 into f dash of x plus y is equal to f dash of x into this guy would now become 2 by 3. Transfer this one here. So I'll be having f dash of x plus y over f dash of x would be equal to f of x plus y over f of x to the power 2 over 3. So we have 2 over 3 to both the powers here also and here also. Now we have to make use of this guy. So we can set whether x is equal to 0. So I'll be having f dash of y over f dash of 0 is equal to f of y over f of 0 to the power 2 over 3. Now f dash of 0 is 3. So let's plug it. So f dash of y over 3 is equal to f of y will remain here only. F of 0 I need to find out. So f of 0 I need to find out. So what we will do here, we have here f of x. So in this star equation, I'll call this equation to be star. So we can plug in x is equal to 0 and y also 0. So in this case, I'll be having the cube root of f of 0 is equal to 2 times cube root of f of 0 plus 1. So this means my f of 0 is going to be 1 minus 2 will be minus 1, and then cube root of minus 1 is again minus 1. So f of 0 is simply minus 1. So when we have f of 0 is equal to minus 1, I can plug in here minus 1. Then this will be what? Power 2 over 3. So I can add on 2, then 1 over 3. So I can see here this minus 1 is getting evaporated. So from this, I'll be having f dash of y over 3 will be equal to simply f of y to the power 2 over 3. And now we can transfer this one here. So I'll be having f of y to the power minus 2 over 3 into f dash of y is equal to 3. And now we'll integrate with respect to y on both sides. So integrating with respect to y on both sides. So in this case, we'll be having integration here dy, then here also integration with respect to y. So f of y power minus 2 by 3, when I integrate this, I'll be having f of y to the power minus 2 by 3 plus 1 is 1 over 3 here, and then here 3. Into this will be equal to 3y. Since this is constant, we can add here 3c so that this 3 also gets wide. And now we need to find out the c. So for c, again, we'll use the condition that f of 0 is minus 1. So this 1 would be equal to 0 plus c. Why? Since f of 0 is what? Minus 1. So from here, we get the condition that c is equal to minus 1. So I can get the function f of y to the power 1 over 3 is equal to y minus 1. So from here, I get f of y is equal to y minus 1 cube. I get this function. Now, what is next? So g of x is f of x minus x cube. So g of x is what? F of x minus x cube, which means I have x minus 1 cube minus x cube. So that is x cube minus 3x square plus 3x minus 1 minus x cube. So these two gets cancelled. And now this is g of x. So what will be g of mod x? You can plug in g of 1. You can plug in mod x at the place of x. So 1 minus 3 mod of x square plus 3 times mod of x minus 3. Now this is minus 3 times mod of x square, which can be written as simply this, plus 3 times mod of x. This is not differentiable at x is equal to 0 only. Rest everywhere, g of mod x is differentiable. So we have only 1 point for this. So answer here would be 1. Now let's go ahead for this. Now we have x naught is a solution of f of x is equal to f inverse of x. So let's find f inverse. So let y is equal to x minus 1 to the power 3. So y to the power 1 over 3 is equal to x minus 1. So this implies x would be y to the power 1 over 3 plus 2. So x is nothing but f inverse of y, which is equal to y to the power 1 over 3 plus 1. You can replace y by x if you're not comfortable. So f inverse of x is equal to x to the power 1 over 3 plus. Now we need to find the solution for f of x is equal to f inverse of x. So let's graph this. So we have here f of x is equal to x minus 1 cube. So this graph of x cube will be now shifted one inverse here. So the graph would go somewhat like this. Okay, at 0 I'll get in. So it's so okay. So this is my x minus 1 to the power 3. And the another one is x power 1 over 3 plus 1. So x power 1 over 3 is the reflection. That means, and that too shifted one bit down. So this graph will go from here like this. This way. This is the line y equal to x basically. So I want to see where is this point, okay, or what is the value of this. This is my x naught. So we need to find out what is x naught. Of course, solving this would be a tough job. So we can predict something from here. I'll define another function. This is what? F of x is equal to f inverse of x. So I define take h of x is equal to f of x minus f inverse of x. So we give you what? X minus 1 cube minus x power 1 over 3 minus 1. So this is my h of x. We can apply intermediate value property and just see where is this x naught, because ultimately we want the x naught is the solution of this equation. So we want this x naught nature also, which is cos inverse of something and then tan inverse. So we need to see what this is going to be. So we can rather find out h of 1 because it's on the right side. So let's start with 1. H of 1 will give me this is 0. This is minus 1 is minus 2. H of 2 will give me 2 minus 1 is 1, minus 1 is 0. So minus 2 power 1 over 3. And h of 3 would give me 3 minus 1 is 2 cube, which is 8, minus 1, and then minus 3 power 1 over 3, which is positive. This is negative, so it's a negative. So we see that h of 2 is negative and h of 3 is positive, which means h of 2 into h of 3 is negative. That means there exists x naught belonging to 2 to 3. Okay, such that h of x naught would be equal to 0. So this is my solution. That means my x naught belongs to 2 to 3. So we now have to find out cos inverse of cos 2x naught. So since x naught belongs to 2 to 3, so 2x naught will belong to 4 to 6. So it is 4 to 6. That means I need to find out what's the nature of cos inverse of cos. So cos inverse of cos graph, if we draw, then this is 0, and then pi, 2 pi. So 4 to 6 will lie here because 2 pi is 6.28. Pi is 3.14. So my graph for cos inverse of cos would go this way. That means my x naught lies here somewhere. This is my x naught. So cos inverse of cos of 2 times x naught is going to be this line equation is what? It's decreasing, so minus x plus 2 pi. So I'm going to have minus of 2x naught plus 2 pi. So we get cos inverse of cos 2x naught is this. So that happens to be my theta. So I get minus theta plus 2 pi. So it's decreasing and then 2 pi becomes 0. And then now we also have to find out tan inverse of tan x naught by 2. So x naught belongs to what? 2 to 3. So x naught by 2 will belong to 1, 2, 3 by 2. That means it is still in the first quadrant only. 3 by 2 is 1.5 and pi by 2 is 1.57. So tan inverse of tan of x naught by 2 will be just x naught by 10. So this guy wants 4 times tan inverse of. So therefore, 4 times tan inverse of tan of x naught by 2 will be equal to 2 times x naught. So after all, we need to add them. So therefore, we get here this plus this. So therefore, cos inverse of 2x naught plus 4 times tan inverse of tan of x naught by 2 will be equal to simply this, and this gets cancelled, and I get here 2 pi. So the answer would be 2 pi. This answer would be 2 pi. Done. So let's go to the next problem. So we have a function f of x is equal to, so f of x is equal to 1 minus x into 1 plus x square. And f is invertible function, its inverse is denoted by f inverse. Okay. So h of x is given to be f inverse of ln of f of x. So we need h dash of 0. So for h is f inverse, that means I can get here f of h of x is equal to simply ln of f of x. Now I'll differentiate this, so I'll be having f dash of h of x into h dash of x is equal to f dash of x over f of x. That's what we have. Now we need h dash of 0. So I'll plug in here in this equation. So this is my star again now. So set x is equal to 0. So in this case, I'll be having f dash of h of 0 into h dash of 0 is equal to f dash of 0 over f of 0. So looking at this equation, so this is my double star. F of 0, if I find out, then f of 0 is clearly visible. It's going to be 1. And f dash of 0 I need to find out. So whether I'll differentiate this function itself. So f of x is basically what? Multiply. So 1 plus x square minus x cubed. So f dash of x would be 2x minus 1 minus 3x squared. So f dash of 0 would be minus 1. So we got this one. Now we need f dash of h of 0. So h of 0 would be simply, I need to find out h of 0. So this will be ln of f of 0. We need h of 0. So h of 0 would be simply what? I have to see where this h becomes 0. Okay. I have to see where this function becomes 0. So of course, at x is equal to 1, f of 1 becomes what? 0. So if f of 1 is becoming 0 and h is the inverse, so f inverse of 0 will be 1. That means h of 0 is going to be 1. And f dash of 1 is going to be 2 minus 1 is 1 minus 3 is minus 2. So we get h dash of 0 is equal to f dash of 0 is minus 1 or f of 0 is 1 and f dash of h of 0 which is minus 2. That means we get here 1 by 2. So therefore 1 over h dash of 0 would be 2. And then if I add it here, I get here answer 5. And then the next part in this question would be to integrate 0 to 1 and 1 minus x into ln of 1 plus x over we have f of x. So f of x is 1 minus x into 1 plus x square dx. So of course this gets cancelled. This gives me 1 plus x over 1 plus x squared dx. This one is everyone's favorite substitution. You can put x is equal to tan theta. So when I put x is equal to tan theta, I get dx is equal to secant square theta d theta. My limits also get changed. So when x is 0, my tan theta is 0. X is 1, my tan theta is pi by 4. And then ln of 1 plus tan theta. Then 1 plus x square is 1 plus tan square, which is secant square theta into secant square theta d theta. So these two gets cancelled. So if I now have 0 to pi by 4 and then ln of 1 plus tan theta d theta. This is my integral I. Now let's go ahead to find out what's the value of this thing. So I'll use the king property. So I can write down 0 to pi by 4, then ln of 1 plus tan of pi by 4 minus theta. So this will turn out to be 0 to pi by 4 and then ln of 1 plus, this is tan pi by 4 minus theta. So 1 minus tan theta over 1 plus tan theta. This could be further written as 0 to pi by 4 and then ln of, if I multiply tan gets cancelled, we get 2 over 1 plus tan theta into theta. Now I can use the logarithmic properties. This is ln2 minus ln 1 plus tan theta d theta. This integral can be separated. So 0 to pi by 4 d theta. Now this is nothing but my again I. So I get 2I is equal to 0 to pi by 4 ln 2. So I will be, this is pi by 4, so constant, so pi by 8 into ln 2. That's the value of this integration. So it is pi by 8 ln 2. Smooth expression. Okay. So we have a real valued function. This satisfies this equation, which is 3 times f of x plus 5 times f of minus x is 4x plus 3. And then this integration from minus lambda to lambda given f of x over x squared plus 4 as 3 pi over 32. Then we have another function g such that this equation is given. Then we want the coefficient of x power 28 to this expansion. That means we need the value of this lambda first. And we also need this function to get the coefficient. So let's go ahead, see what do we get. So I'll just attack this guy first. Since integral minus lambda to lambda, I have f of x over x square plus 4. This is equal to 3 pi by 22. So again I can apply King's. So minus lambda to lambda, f of minus x I'll be having, and then x square plus 4 dx will be equal to what? 3 pi by 32. So I'm going to add, this is my equation 1, this is 2. So let's add both of them. So this gives me minus lambda to lambda, f of x plus f of minus x over x square plus 4 dx will be equal to 3 pi over 16. It's 32. 2 by 32. Now we want f of x plus f of minus x. So we have this equation. I'll call this star. So we want f of x plus f of minus x. So what we can do is, in star, we can replace x by minus x. So replace x by minus x. So when I do this, I'll be having 3 times f of minus x plus 5 times f of x is equal to minus 4x plus 3. And this is my double star. So if I add star and double star, so adding star and double star. If I add these both, so I'll be having 8 times f of x plus 8 times f of minus x is equal to 6. So this implies f of x plus f of minus x will be equal to 6 by 8, which is 3 by 4. So now my this integration will be minus lambda to lambda, 3 over 4 times x square plus 4 dx will be 3 pi over 16. And then politely we will cancel 3 here, this 4 also. So pi over 4. And if you see here that this is x squared plus 4 is an even function, so we can write on here, but 2 times integral 0 to lambda 1 over x squared plus 2 squared dx. This is equal to pi over 4. That means I'll be having 0 to lambda 1 over x squared plus 2 squared dx is equal to pi by 8. 2 I have taken down. So by what I have now, if we consider this thing, then this is nothing but 1 over 2, the tan inverse of x over 2. My limit goes from 0 to lambda, which is equal to pi by 8. So from here I get half of tan inverse of lambda by 2. Tan inverse of 0 is 0. So we get here pi by 8. So this 2 will compensate here, and tan inverse of something is pi by 4. So lambda over 2 must be equal to 1. So this implies lambda is equal to 2. So that lambda is equal to 2. And now we have here, so lambda is obtained. That means now the next part is to get rid of this thing. So we have integral 0 to x, and then g of t minus 2 square. So g of t minus 2 square dt is equal to x plus 4. So let's differentiate both sides. So when I differentiate, I'll be having here g of x minus 2 square is equal to, this is 1, same thing. So that means my g of x will be equal to 1. So x square minus 4x plus 4 plus 1. So g of x will be simply x square minus 4x plus 5. So this is my g of x. Now if we go to this, then we want the coefficient of x power 28 in the expansion of g of x plus 2 lambda times x minus 1. So g of x plus 2 lambda times x minus 1 to the power 15. How would this expression look like? So we have 2 lambda, so lambda is 2. So g of x is basically x square minus 4x plus 5 plus lambda is 2. So again I get 4x minus 4 power 15. So we see that this also gets cancelled, and I am left with x square minus 1 to the power 15. Now x square minus 1 to the power 15. So anything here would look like this. TR plus 1 is equal to what? 15 CR x power 2 to the power 15 minus R minus 1 to the power R. That's what I have in the binomial, and we get the coefficient of x power 28. So that means 30 minus 2R should be equated with 28. That's not impossible. Coefficient of x power 28 is required in this exponential. So g of x is g of x plus 2 lambda times x minus 1. So power 15 is equal to 30. So from here I'll be having 30 minus 2R will be 28. Oh, I thought here R will be 28, but that's not correct. So this means R must be equal to 30 minus of this. So R2 is equal to 2R, means R is equal to 1. So when my R is equal to 1, just click and plug it here. So this gives me T2 is equal to 15 C1. Then this is gone, and then minus 1 to the power R. So that means we get here minus 15. So therefore coefficient of x to the power 28 is minus 2. So that's here will be simply minus 15. Let's go for the next one. All the way about to infinity. This part is the water. floor of x, also called as the greatest integer less than or equal to x. And this notation will stand for the ceil of x, which is nothing but the least integer greater than or equal to x. So that means we now have 1 to infinity. So of course, these guys demand unit integer. That interval should be of unit length, both of them. So that means when I have here 1 to infinity, have one over LIF of x square into GIF of x square dx. This will be written as 1 to 2, 2 to 3, then 3 to 4, and so on. So GIF of x square into LIF of x square, plus same story here also, GIF of x square into LIF of x square dx. This will go. That means we can now write down this as summation. N starts from 1 and then goes up to infinity. Integration of n to n plus 1. Then we have here GIF of x square into this thing. That's what we can write down because I can put it in the iteration for infinite series. And then if you notice here that sigma n is equal to 1 to infinity n to n plus 1. So this is my floor. Okay. This is C. C we have to take. So ceil of x is going to be what? N plus 1, the least integer. That means upper part we have to take. And GIF of x is simply n to n plus 1 is n square. That means it asks us to find only the sum of the series. So the series is what? Basically, sigma n is equal to 1 to infinity, 1 over n square into n plus 1 square. So this could be further written as sigma n is equal to 1 to infinity. Then we can do the partial fraction here. So 1 over 1 over n plus 1 the whole square. This I can write down n is equal to 1 to infinity, 1 over n square minus plus 1 over n plus 1 square minus 2 over n into n plus 1. So now we can expand the series everywhere. So n is equal to 1 to infinity, 1 over n square plus this will be series again. N is equal to 1 to infinity, 1 over n plus 1 square minus 2 times sigma n is equal to 1 to infinity, 1 over n into n plus 1. And this one we are given the fact that this series is nothing but pi square over 6. It's given here that 1 over n square is pi over 6. And this is nothing but this series starts from 2. So which is nothing but pi square over 6 and then minus 1. And then now minus 2 times the sigma. So sigma n is equal to 1 to infinity. We can factorize it. So I'll be having 1 over n minus 1 over n plus 1. And then we can apply telescope. So the telescoping sum will be simply what? 1 over n minus 1 over n plus 1. So the series would go on. And then we have here pi square over 3 minus 1 minus 2 times. If you see this, so this is, then please one can assume that I'm writing the limit part. So basically the last part I'll be writing here. So this, when I'm writing n is equal to 1, I'll be having 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 and so on. So all of these will be evaporated. So I'll be having simply pi square over 3 minus 3. So the rest of them will get cancelled. So this gives me pi square over 3 minus 3. Move to the next. This problem is asking us to find the sum of n is equal to 1 to infinity. The two series are there. So 1 over 2n plus 4, then minus 1 over 2n plus 5. Separating this series would be a bad idea because if we just go over this thing, so we have here this series, if I consider any one of them simply up to 0 to infinity, then this is basically the harmonic series. So the harmonic series sum is divergent. This is not convergent basically. That means it does not have a finite sum in case if we're concerned. So it does not have finite sum. But that doesn't happen with the sum of two divergent series. So we can think of solving this one. So n is equal to 0 to infinity 1 over 2n plus 4. So we will take help from the integration. So I'll be writing n is equal to 0 to infinity. This 1 over 2n plus 4 can be written as integration 0 to 1 x to the power 2n plus 3 basically. Because if you integrate this thing, you get 1 over 2n plus 4 in the denominator. The same thing I can do here. So I can write down again 0 to 1 x to the power 2n plus 4 dx. And now this integral is of course convergent. That means I'm left with 0 to 1. And then sigma n is equal to 0 to infinity. Then we have x to the power 2n plus 3 minus x to the power 2n plus 4. And then we have here dx. That means now I can write down 0 to 1. This will be nothing but sigma n is equal to 0 to infinity. X power 2 will be common. X power 3 also we can get common, and we get 1 minus x and then dx. This can be further taken as integral 0 to 1. And this is sigma n is equal to 1 to infinity. So I'll transfer the remaining things outside. So now we have sigma n is equal to, starts from 0. Okay. So n is equal to 0 to infinity. We have x to the power 2n. So our entire concern will now be shifted to this, because we have x cubed into 1 minus x waiting in the corner. Yeah. So let's go ahead. And this, if you see, then it's a GB basically, with the common ratio of x square, and the first term becomes 1. So we get 1 over 1 minus x square, simply. So this sum we have got this. Then we have here x cubed into 1 minus x into dx. So this could be again written as 1 over 1 minus x into 1 plus x. Then x cubed, and here we have 1 minus x into x. So these two gets cancelled. Then this is 0 to 1, x cubed over 1 plus x integration limit 2. So 0 to 1, I'll think of bringing the partner for x cubed plus 1. That's nothing but x plus 1. So I can write down like this, plus 1 and then plus 1. And this would be x plus 1 dx. This in turn gives me, all right, I'll write it here. So 0 to 1 and then x plus 1 into x square minus x plus 1. This over x plus 1 dx, and the next part will be 1 over x plus x from 0 to 1. Now these two gets cancelled politely, and here x square integration between 0 to 1 would be 1 over 3 simply, minus 1 over 2, then plus 1, minus this will be ln of mod x plus 1, and limit goes from 0 to 1. So 1 over 3 plus 1 will be 4 by 3 minus 1 over 2. Minus this will be ln 2 simply, ln 0. So 8 minus 3 is 5. 8 minus 3 is 5 over 6 minus ln 2. So the answer to this series is going to be 5 over 6 minus ln 2. 5 over 6 is ln 2. That's the answer to this series. Now, with similar notations, there is one more problem which you can try. You can pause the video right now. You can try this problem. This is exactly on the same lines, and answer you should get is what? ln of 2. Please do let me know in the comment. I always read your comments and try to reply. Please try this. Come to the next question. So we have a non-constant differential function satisfying f of xy is equal to f of x into f of y for all xy. Then we have f of 1 plus x is equal to 1 plus x into 1 plus g of x. This thing happens and this thing, then we need a dash to it. Okay. So f of x into y is equal to f of x into f of y for all xy belonging to R. That means my function is going to be f of x is equal to x to the power n. This is the functional which satisfies this thing. And now we have this guy here. So f of 1 plus x is equal to 1 plus x into 1 plus g of x. That means I should try to find out the condition on f dash, because we have f of 1 is equal to 1, which is quite obvious. That means we don't get what is the degree here exactly, because we need f dash of 2. So from here we need to get something from on f dash. That means by the law of common sense, I should think of finding here something. So let's go ahead and f of, okay. So f of 1 plus x, then I'll transfer here. Minus 1 is equal to x into 1 plus g of x. Can you do this? This 1 I need to manage. So 1 is nothing but f of 1. So I can write down f of 1 plus x minus f of 1. I'll divide by this x is equal to 1 plus g of x. And just if I take the limit here as x tends to 0, because this information I can use. So taking limit as x tends to 0. So limit as x tends to 0, I'll be having limit x tends to 0. I have f of 1 plus x is f of 1 upon x. It's nothing but this is constant, so no point. Then 1 plus limit x tends to 0, I have g of x. So this guy is nothing but you see here f of 1 minus f of 0 over 0. That means I get here simply f dash of 1 will be equal to this is 1. And limit is given to be 0. So I get f dash of 1 is equal to 1. That means from here I can differentiate this star equation to get my 1. So f dash of x will be equal to nx in minus 1 in the power nx and minus 2. So that means f dash of 1 is 1. So this forces n to be 1. So the function becomes f of x is equal to simply x. So we get here f dash of x is equal to 1. Now you plug in here 2, or you plug in here 3, that is your choice. Answer will be always 1 of x. Okay, so thank you so much for watching. We'll see you in the next session. Have a good day.